All right, let's look at this example. Find the linearization of this function at a equals 1 and use it to approximate f of 1.1. All right, so the linearization, really all we have to do is come up with f prime of a, or f of a, f prime of a, and just plug into here. So let's see, our a in this case, they told us is 1. So f of 1 is going to be 2 minus 3 plus 4. So that's 3. And just plugging into here, we get the linearization is f of a, which is 3, plus, oh, we got to find f prime of a. Well, f prime of x is 6x squared minus 3, and f prime of 1 is going to be 6 minus 3. Total coincidence that both of these are 3 here. X minus a. A is 1 here. So let's see. I'm going to draw some arrows here just to show where this stuff's coming from. So we get linearization is 3 plus 3x minus 3. So I just get 3x. So that's my linearization. And it said approximate 1.1. So f of 1.1 is approximately equal to L of 1.1, which is just 3 times 1.1, which is 3.3. All right, just for fun, let's look at this on Desmos and see how it compares. All right, so our original function here is 2x cubed minus 3x plus 4, y equals that. And this is supposed to be approximating this at the point 1. Let's see, what is the point? At 1, that's the point 1, 3. So this linearization, L of x, is, what did we come up with, 3.3x? No, just 3x. Yeah, so sure enough, that's the tangent right through there. I'm going to come back up here and change this to f of x. So if you look at this, f of 1, f of 1.1 is 3.362, and L of 1.1 is 3.3. Move that up. So it's not a bad approximation. All right, let's look at this next one. Use a linear approximation to estimate the cube root of 8.07. Compare the approximation to the actual answer using a calculator. Okay, so 8.07. Now, this is very close to, well, first we have to decide what our a is going to be. So what's a number close to 8.07 that has a nice cube root? Well, 8. Cube root of 8 is 2. So we will use a equals 8, and we know that the cube root of 8 is 2. All right, so my f of x here is cube root of x, which of course is also x to the 1/3 power. And I'll copy this from above. The linearization is equal to f of a plus f prime of a times x minus a. All right, so f of x is that. F of a, let's see, a is 8. So f of a is f of 8, which is a cube root of 8, which is 2. f prime of x is 1/3 x to the minus 2/3, or in other words, 1/3 times x to the 2/3. And f prime of a, that's f prime of 8, is 1/3 times 8 to the 2/3. All right, 8 to the 2/3. The way you do that is you take 8, you square it, and then take the cube root. Or maybe it's easier to take 8, take the cube root, which is 2, and then square that, which is 4. So I get 1/12. So now if I just plug into here, I get my linearization is f of a plus f prime of a times x minus a. So I get that, and let's write it out. Let's put it into y equals mx plus b form. That's 1/12 x minus 8/12. Let's see, what is 8/12? That's divide them both by 4, you get 2/3. So that's 1/12 x plus, let's see, this is 6/3 minus 2/3 is 4/3. Keep in mind, this, we call it L of x. All it is the tangent line at x equals a. So that's our L of x, and it said we need to find this L of 8.07. L of 8.07 is 8.07/12 plus 4/3. All right. Now I'm going to put that into my calculator. You might say, if you've got a calculator, why do all this other stuff? Well, maybe you got a calculator, maybe you just have a little 4-function calculator that can't do cube roots. If you did that, this might be useful. All right, when I put that in here, it actually gives me a fraction, 2407/1200, or 2.0058, and then 3's that repeat forever. So let's compare this with calculator. Now, my calculator, it might have a cube root function on it, but I'm not sure. What I'm going to do is I'm going to put in 8.07 raised to the 1/3 power. That gives me this. And that's pretty close. I'm going to put the other one in there. 8.07/12 plus 4/3. So this is the actual cube root on top, and then the approximation that we got on bottom. And those are pretty close. They are equal up until the 4th decimal place. And after that, they're off by a bit. But anyway, it is a good approximation. All right. We've got some, let's see, one more example of this. This video is getting kind of long, though. I'm going to do this example of cosine 60 in the next video.